Hi, my name is Mikkel, and in this example I'm going to show you the importance of documenting your screw piles correctly. This example will be based on 6 years of research conducted in Aalborg University's sandpit. In their sandpit, they can precisely control the sand's density and friction angle, so it makes it a perfect situation to detect the kinds of influences different components of the installation have on the bearing capacity. In this example, we are going to look at something called the advancement ratio. The advancement ratio is essentially the ratio of the installation or penetration per rotation to the screw pile pitch. If it is installed perfectly, those will be correlated and you will have an advancement ratio of 1, meaning that per rotation you go down 1 pitch. If you don't install it correctly, for example if you only go half the pitch down per rotation, you'll have an advancement ratio of 0.5. And what essentially is happening is that you're transforming your screw piles from a screw pile to a drill. So you're losing the soil all the way down into the bearing strata. And this has a significant impact on bearing capacity, as this example will show. In this example we are installing 4 piles. All piles have a diameter of 76 mm and a T12 thread. Pile 1 was installed with an advancement ratio of 0.5, meaning it rotates twice before going the height of the pitch down into the ground. It measured a torque of around 1700 Nm during the last rotation and was installed at 10 RPM. In these tests we control the soil profile, pile geometry and speed, so they are the same for all 4 piles, where the only thing we actually vary is the advancement ratio. If we look at pile number 2, it's the same pile type, installed with an advanced ratio of 0.8. It measured a torque of around 2300 Nm during the last rotation and was also installed at 10 RPM. Pile 3 perfectly installed, with an advancement ratio of 1. It's the same pile type. It measured a torque of almost 2,700 Nm during the last rotation and was also installed at 10 RPM. And then the last pile, pile 4, was installed with an advancement ratio of 1.1, meaning that we are pushing it a little bit into the ground compared to rotating it in. It measured a torque of around 2,800 Nm. And it was of course also installed with the 10 RPM. But if we look at the bearing capacity from the static test, the first pile had only 15 kilonewtons because we are installing the screw pile as a drill, so we are loosening the soil around the screw pile, which will create a large amount of sediment that could cause the building to fail. Pile 2 had a bearing capacity of 35 kilonewtons because it was installed slightly better than pile 1, just within the recommended limits of the advancement ratio. And then pile 3, which was installed perfectly, had a bearing capacity of 50 kilonewtons. The same goes for pile 4, which also had a bearing capacity of around 50 kilonewtons. So from this you can see that the worse you install the screw piles, the lower the torque will be, but especially the bearing capacity will drop quite dramatically when you don't install your screw piles correctly. Therefore you must measure the advancement ratio as you install the screw piles. Without it, you cannot control or document the bearing capacity for piles that you don't test. Which means that if you don't measure the advancement ratio of your installation, you will need to do a static load test of each single pile to be able to document your project correctly. I hope you found this information useful and that it provided insights into the importance of correctly monitoring and documenting a screw pile project. Follow for more information where we will look into other examples and important areas when using screw piles in your project.